Okay, should I go ahead?
I would also give a short introductions of the talk of our evenings.
Yeah.
Okay. Give me a second. Kind of lost my screen. Too many screens. I'm sorry. So the talks of the evening are from WebDave. 5 things you probably won't know about Angular. Dave is a passionate developer and curious nursery child. He developed web applications for almost 2 decades, amongst others for Olympus, Telefonica, Hermes, and has been imparting his knowledge of JavaScript and Angular in workshops since 2014. Dave is also involved in the Angular community and organizes the Meetup in Hamburg. And on top of all of that, he recently started streaming on Twitch as WebDave. I think it's not that recently. But and our second talk of the evening after the break will be Git under the Hood from Zvonimir. And Zvonimir is a passionate software developer, highly interested in software architecture and getting it right. Outside work, he likes to keep his mind sharp and body strong by doing different recreational sports. Zvon enjoys reading a good book, listening to all sorts of music, and dogs. You can see those even on Twitter. So I would give the word to Dave and have a lot of fun with the talks.
Thank you for this kind introduction and start for this. Let me share my screen. So, okay, this is the right screen. Yes, share it. Okay. So there is a not that serious meant stamp top secret. So maybe you know some of these techniques from Angular, but mostly they are very, very rarely known, and some of them I never found some documentation about this. So maybe it's really a well-kept secret in Angular. So let's have a look on this. First of all, hi, I'm Dave. As Karina said, I'm doing development since 2 decades, which means I'm old, kind of. I'm a GDE. I'm a web developer since many years. I'm freelancing and so on. We had all the information about this. You can reach out to me on Twitch, Twitter, or Instagram. My handle is always webdave_DE. On Twitch, I'm every Tuesday night. I'm live streaming, and doing some fun stuff. So I don't plan anything. It's very, very chaotic and spontaneous topics I will talk about there. It's German content, so if you can ask questions in English, I answer them in English, but the main language there is the German language. And if you want to see the link, it's down there, webdave.tv, and you can. It's just a forwarding to my Twitch channel. Okay, and I'm active in communities, so which means Germany, Austria, this one, and Switzerland, and Hamburg, and I'm one of the organizers of the team members of NGDE, which is a conference about Angular, which will take place in September 2022, and so. Be sure to follow me on Twitter or on Twitch to get notified when the ticket sale will start. And for sure, there will be a call for paper if you want to share your knowledge on stage. Okay, and I'm doing music in my free time. So that's it. That was the icebreaker. Okay. And as Karina mentioned, I mention this all the time because it's very important. Please be kind. And everything I do is under the Berlin Code of Conduct. So don't be an asshole. Just be nice to each other. Okay. From now, maybe I should whisper. I'm not sure. No, I don't. Okay, top secret. So the first techniques I want to show is the slot. I name it the slot machine. And I know it's not the real name from this, but I'm naming it like this. The slot machine. Maybe you know there are slots in HTML, HTML. And since HTML5 you have slots, then you can define positions or DOM nodes which you can refer and set things in it. It's very it's a technique from the web components or custom element stuff. And we have the same technique in Angular, ng content. It's there since it has been there forever. It was in AngularJS. And how does it work? It means you can write code, HTML code between your template text, your template text, and then this will be projected on the location of your DOM of your component, and you will see this kind of stuff. So you can write, for example, some skeleton code, and then project values through this content stuff to your template. This will be the result of this. But that's not enough. The very powerful micro secret is here. Micro secret, nice work. You can refer. You can have multiple ng content or slots, and you can prefer to specific DOM nodes by selecting them via the standard CSS selector. Means you can say, okay, in this slot, I want to have the content from the element which will be found by the attribute image, this one, or by the attribute name, or and so on. You can also go there by select them or refer to them by selector ID or by tag name and so on. So just the standard CSS selection way we have to go there. And so this is the way we can build this kind of skeleton and then just project the content at a specific place. Yeah, how does it look like? It's something very easy, so don't spoiler here. So this is I wrote here two components with this where I use this ng slot stuff. First of all, the standard hello components component, which is generated by the StackBlitz stuff, and I have just one single DOM node, the h1, and inside here you can see, okay, we have just the ng content, and this is here on this. And in the next one, when we take a look here at the vcard, which is more useful in my opinion, you can send specific DOM nodes to this component and refer to them in the template of this. So it means you can go here and say, okay, we have this is our stuff, and then you can say, okay, this here is the image, as I said in my slides. And when we check this in the DOM, we check it, you can see that it is just this template. So as it looks like you just sent all the template to this, and this is the main power, that we don't have any leftovers from this ng content. I love this feature. Okay, this was the feature number one. Maybe you know this, but we have 4 to go, and maybe it's getting more exciting. Next one is a feature which is really yeah, there is one sentence in the documentation about this, and it's not that well known. You all know that we have this kind of attribute binding, or this kind of ball in a box binding, yeah, input output binding. You know, we can have input binding in our component, and output binding means we can reflect the data from a tag from our component to an attribute for our class. When we send here some data into the user attribute, then it will be projected to the user attribute of this class. And we have the possibility by using the output decorator to define a custom event so that we can trigger an event like emit, and then we can send data out. So we have now the way in is the user and the way out is the update. But very often I see this is all we want to do with this kind of stuff. We want to send something in and get more or less the same but bit modified item back. And therefore there's a very useful and very easy way to get this done, to use it in this ball in the box syntax. And the secret is you can have an input which is named any name and an output which is this exact same name plus change. This means you can use this ball in the box syntax for this attribute. So then this is the two-way data binding for this. So you can do this. Maybe you noticed that we have some for example, for if you have ever worked with reactive forms, for example, so this form control has the value and the value change, same stuff, or an ng module and the ng module and the ng model and ng model change, also same stuff. And you can go ahead and write the same code, just end it with change, and then you can use it with this syntax. So thumbs up, please. If you say this was new to you, then I'm very happy about this. Okay, and just to prove it, go to my, I guess, no, this one, this here, yeah. I just wrote a small list, a list with just some data, and here is my table, and I wrote a component which is just a standard search component to search stuff in my list. Yeah, the search component is I've written has an input, it's named search, and an output search change, so that I can use this two-way data binding syntax. And when I start here typing and type, for example, what? Find it, and then I do some whatever. Okay, I guess I can go and say, okay, here, the HY, and then Timothy is found. Then that's the proof. This is a very easy way to use these two-way data binding in your component. So you don't have to bind special way and have some secret members in your class to trigger and working with setters and getters. This is a very easy way to achieve the same. The third one, oh yeah, the third one is a very nice one. Maybe you notice we have very standard way to use modules and configure modules in Angular. So there is very often you have this for root method inside of a module, or for feature or for child. You know this maybe. It's very common. You see this on, for example, everything which is with this store stuff, effective store router connection, whatever. Very important, very famous. The router module also has this method. This means normally we especially in these kinds of modules, the store module and for and very important, the router module, they are singleton. So we have only one instance of this module, which is very important because if you think about, you have multiple router modules, they interact and react by observing the events of your navigation, and multiple router modules would interact or trigger some actions when there is a route change. Then you will mess up with a maybe an infinity loop of navigating and forwarding and so on. So it's important that you have only one instance of this. So we need a way to instantiate it. This is the method for root, and we need a way to extend maybe the existing instance. This is then used by the router. The method is for children, and by the store, for example, is for feature. This for root method just returns module with providers of this module. This is just a type. Okay, so you can see it returns the ng module, but it returns itself. So this is the way we can use it. This is the actual code of the router module. So what is now my favorite feature, and my favorite hidden feature is you can use or you can build your own module and use this feature. Yeah, you can define a static for root module method, and you can then send data to this for root method, like I did here with this config. And then you can return not only the module, but you also can return this config as a provider. So you generate it called a dependency, the dependency token. Oh, lost in translation, nearly. Okay, dependency token. So it means you can define an injector token for this config in this case, and then you can get this config in every service, component, directive, pipe, whatever, via dependency injection, like this. And you can use it everywhere. So you don't have to come up with a service which you want to steadily define inside of your module. You can use this just to give the user of your module or of your library the possibility to provide or generate own provider token like this. What does it mean? How it does look like? It looks like this. Now we have here our mylib module. Is very genius way, I know. And inside of this, I just said, okay, we send him an object-based URL and my URL to my Twitch account. And inside of this, I said, okay, I want to share this as this injector token, and then you can use this everywhere. You can use it here inside of your module, but you can also use it here inside of your other components. It depends on where do you import the module. Now, this module is imported in my root module, so the providers are available in my root level or level of my application. So very strong and powerful feature. And a very quite big myth about this, how this works. Very easy. I try to come with very easy and short explanation about this. Okay, next one is I thought about how I would name this, and I came up with this. I know this is not a real name, yeah. It is just I invented this. Okay, this is parental. I can't pronounce it. Parental tokening. So tokening is a very important word for me because it sounds funny. Parental. Okay, what does it mean? It means, you know, that we can have, we have components, and we have an app component, and in our app component, we have another component, which is in a template. And now there is this standard parental tokening feature, how I named it. This is, I've never found any kind of documentation with. In every component, you can get the direct parent. So the parent, not the grandparent, the parent via dependency injection. Yeah. So why is this useful? You could say, right, we can go, what is the why is this a good thing? You could go and send data to it. Okay, wait. We just talked about input and output. So couldn't we go here and send it via input to this component, to the child component? Yeah, but there are situations where you don't have access to the input binding. Think about routing. If you think about routing, then you don't have the possibility to send data to a component. And this is the moment where this comes in handy. Okay, you can use via routing, you can use this feature to get information from the router parent. Oh, no, this one. No, my StackBlitz. I also have a StackBlitz here. This one. Okay, router parent means we have here, this is my route. We have here just one route, okay? And by default, we go there and send it. This hello component is my default route. So this is here. And when we go here, then, and we type here some stuff, we see this is the component. And this is the situation where I found this very often very handy to get information from the parent without instantiating any services or provider tokens. Just use the provider token of your parent component to get the data from them. That's it. Very easy way and very secret. I'm not sure why this is I never found the documentation about this, so there's not a single word about this in the documentation. I don't know why, but this feature exists, and it exists since ever. Maybe I should send a PR and for the documentation about this. But maybe there's some reason why they don't use this. But I don't know why. So to use this via routing or via rerouting, this is a very handy stuff. But I wouldn't use it if I have the possibility to use input-output binding, because this would be something we can use to use the dependency, the change detection for some tricking the template stuff. And this maybe is here a downside by this, but this is a very easy way to use this. Okay, and the last one, component factory resolver. Maybe you heard about this. This is something very strange. So the component factory resolver is one of the funniest things by naming in the Angular code, because it exactly says what it does. It's a component factory resolver. I really love it. As far as I know, the guy who implemented this was a German guy, and I talked to someone of the Angular core team, and he said, "Oh, wait, you are also German, so you are very specific by naming your methods and your classes, right?" And I said, "Very often, yes." And then he told me that this feature is implemented by someone from the German. A German contributor of Angular. So it's a factory which has a resolver, and so they named it component factory resolver. But what is this? Many code. Let me explain. Sometimes not the normal way to get a component inside of the DOM is to write the template, the tag, the HTML tag there, and then the template engine. In our case, it's since Angular 9 plus, it's Ivy. Hopefully, since 13 is only Ivy. So Ivy will come up and instantiate the component, and then build it into your DOM and instantiate the component and starting doing the stuff. So this is what happens the normal way. But sometimes you need to instantiate the component via code. Example is if you want to trigger a toast message, for example, or if you want to start something like a modal this is something very common stuff. What happens that you have a model, a container, and then you want to generate a component inside of this container. And this is the stuff we use there. So there's the factory resolver we can use there, and you can have every view container. View container is the container of your template. Your template is based in the view container, and you can get the reference to it. And this container has a method create component, and you can send them the factory, the resolved factory of your component in there. What does it look like and why? So this is a feature which is not very secret, but it's very, it sounds very complicated. And I will try to simplify it. So I also have here, not a StackBlitz. In this case, I have a local, because StackBlitz is not working for me at this kind. Because I want to show something very great. So this is exactly the same code. We have a button which says, hey, show hello, and show hello says, okay, we get the component. This is the component, just an h1 tag and an attribute and just a class. So get the component, resolve it, and then send it to your the create component method. And you can see there's a hint here. So the create component is, this implementation is marked as deprecated. And there's a very easy way to generate components dynamically. It's very easy nowadays. And this is, the code we are seeing here is valid Angular code until version 12, okay? Beginning from version 13, this will be marked as deprecated. So the not deprecated way is this. Awesome. So we can just send the component to this create component method, because all these resolver methods, we know these are all methods we needed to, they have been needed by the and used by the view engine. View engine was a template engine which was there before Ivy came in. Okay, so since Ivy, we don't need any factories and factory resolver, so we can get rid of everything which is called factory or factory resolver. Just delete it, and there is a better implementation. And this is the implementation how you can create component dynamically now. So that is my, let me just show that it works. When I click here on say hello, yeah, then we get the component ref, so the view container ref, and then we create this component. Okay, so that's it. So I click here and hello component, and now we can go ahead and click it until ever and scroll. Yeah, so this is a very easy way to generate component or create components into your DOM. Just the very simplified way to create component methods. And I need this. Yeah, there was a StackBlitz, but since last week this is outdated, because since Angular 13 we don't need this factory resolver stuff. So and StackBlitz isn't able to instantiate Angular 13 applications at the moment. So I'm waiting for this. So until this, we have to go for a local example. That's it. That has been 5 more or less hidden features in Angular. And I hope you enjoyed it. If there was something new to you, feel free to give me a thumbs up or a clap. Thank you for this, Santosh. And yeah, I'm happy to see this. Okay, this is deprecated from, okay, yeah. Andres came up with the information that it is deprecated. Yeah, exactly. Okay, I stop sharing and you go ahead. Stop sharing. Oh, here. Yes.
Has anyone questions today?
Yeah, I have only one question. In injecting the parent component, why does it have to be public?
Oh no, it don't have to be public. I just did it public. Wait, let me just share it again. I just did it public because I was lazy. Wait, let me go for this. No, this one. Yeah. This, where was it? Can't find it. It deleted itself. No, yeah, I just did it because I want to use it here in the template. And if you want to use it in the template, it has to be public. No, it's just to be clear, it's not a good idea to use injector tokens in the template, but this is just a POC. So I used it.
And in general, do you think it's a good idea? Does it make it harder to understand what's going on in the app?
No, I love this idea when it comes to routing, but if I want to use it in the in normal template like here, then I would definitely go with the input attribute binding to send data to this. Yeah.
Thank you.
Okay, more questions? Otherwise, go ahead, Karina.
Okay, if there are not any more questions, we can decide if we make it break. I would probably recommend at least a 5-minute break to refresh yourself, get some more drinks or something like that before we then start with the next talk. Okay, then we see each other in 5 minutes, so around yeah, let's say 10 minutes before 7. Okay. Welcome back, everyone. And then I would give the word to Zvonimir, and hope you all enjoy the talk about Git under the hat.
Okay, I'm gonna then share my screen. Thank you all for coming. Karina, thank you for inviting me, and thank you, Dave, for a nice talk. Since I'm not an Angular developer, it was all new to me, but it was a really nice talk. And yeah, hopefully you can all see my screen and we can actually start. And yeah, I am going to talk about Git, which is, yeah, Git, right? It's a versioning control system that everybody uses and nobody seems to understand it, right? I am joking a bit. It's a bit of an exaggerated statement, as this comic is. As every joke is, right? It's a bit of exaggeration, but as with every good joke, there is some truth to it, right? Git is widely used today, but most people are pretty basic when it comes to using Git. And actually, most people are kind of afraid of Git because we are never sure when everything is kind of going to blow up. So why is this the case? Why is Git so hard, right? Well, let's say the trouble with Git, for better or worse, is that the UI that Git gives you, and by UI, the user interface of Git, I mean that set of commands that Git gives you, the usual set of commands that you use. This UI is something that's like a school example of what is called a leaky abstraction. And what this means is that Git's UI is not doing a very good job of abstracting away the complexity, the inner details of Git. So as a consequence of this, if you want to get comfortable with Git, you just need to invest some time into learning how it works under the hood, how it works internally. Because if you don't, no matter how long you use Git, it will forever confuse you, because those commands, those messages that Git gives you, they will never make sense unless you know how Git works internally. Now, I know this sounds like bad news, right? Because who has time, or who wants to go dive into internals of a certain tool? But there's some good news as well. So the first piece of good news is that you don't actually need to learn the ins and outs of all the bits and pieces of Git. Just by understanding what I am going to talk about it today, I believe your level of comfort in your everyday work with Git will skyrocket, and it will be enough for you to become a much more powerful, if not a power user of Git. And another piece of good news, and this one is a bit more opinionated, is that, and I'm sure at least some of you will agree by the end of this talk, is that Git is actually a cool tool. Once you see how it works under the hood, you will come to appreciate it as a cool tool as it is. But as I said, this piece of good news is a bit more opinionated. So to start, let's paraphrase the great late Carl Sagan, who said, he kind of said it, if you wish to create the universe from scratch, you must first initialize your repository. So let's do that by opening our favorite command line interface. We type git init. Git gives us this message that is one of the rare occasions where we can actually understand what Git is trying to tell us. And what Git is telling us, it has created this .git folder in your project directory. And if you never went and took a look inside, this is how it looks. It has some folders, it has some files. What we are most interested today, and what is most important about this folder, is this head file and these objects and refs folders. Objects and ref folders, they are now empty. I mean, they do have these subfolders, but there's no objects in them. So let's change that. Let's fill them up with some data. So let's say we want to build a startup that will make the world a better place, right? And maybe as a side effect, earn us some money in between. We need an index.php. So we open it in Vim. We add some code to it. Hopefully we know how to exit and save in Vim. So we add a readme.md file because somebody will have to make some sense out of the mess we're going to create. And then we again save. Now we add these files and we commit them, right? This is the usual workflow we get. We all did it probably 10 times just today. So now we have our first commit. So let's go back to that Git folder to see if there are now some objects there. So we're going to take a look at that git/objects directory, and sure enough, there are some objects there. And actually, there are 4 objects. So Git has created these 4 objects to represent those 2 files that we committed. So let's now take a look at in a more visual ways way, what are these objects, what types of objects Git uses to represent our files. In other words, we're going to take a look at Git's data model. So first type of object that Git creates when you commit some files are the so-called blob objects. Blob objects are used in Git to represent the content of your files at the point of the commit. So we committed 2 files, so there's going to be 2 blob objects. And the way Git creates them is Git takes the full content of your file and puts it into the blob object. So there's one blob object for index.php, one for readme.md. And the second step of creating this blob object is that Git will generate what is called a checksum header for each of these blob objects. And the way Git generates this is Git takes the full content of the object, in this case, the blob object, feeds it to a hashing function, and the output is the checksum header. Now, here, the checksum header is, as you see, a 6-character string. In reality, it is a 40-character long string, but 40 characters wouldn't fit my nice image here, so I'm just displaying the first 6. But also, in reality, when you are using these checksum headers, maybe you are passing them as argument to Git commands. You can usually get away with just using the first 6 or even less characters because this is a hashing function that generates them. So the probability of collision is not that big if you don't, so you don't have to use the full 40-character long string as a checksum header. So at this point, Git has these blob objects. So Git has a way of representing the content of your files at the point of the commit, right? Which is great. But if Git wants to reconstruct the whole project state at the point of your commit, Git needs to know some more information, right? Git needs to know how to name these files and where to put them in your project directory. And this is where another type of object comes into play. And these objects are called the tree objects. Now, here we have a really simple folder structure. We only have 2 files, right? There's no folders, subfolders. So Git will only use one tree object. And this tree object has a list of our files, index.php and readme.md. And every file in this list has a pointer to the blob object representing the content of this file. So index.php points to the blob object representing the index.php, content of index.php, and readme.md points to the blob object representing the content of readme.md file. And what are these pointers? They're just the checksum headers of the blob objects themselves. And finally, Git generates the checksum header for this tree object as well, in the same way as before. Git takes the full content of this object, the tree object in this case, feeds it to a hashing function, and the output is the checksum header. So now, at this point, Git knows what the content of your files was at the point of the commit. It knows what the names, how to name your files, what was the name of your files at the point of the commit, and Git knows where to put them in your project directory. So basically, Git has all the information it needs to recreate the state of your project at the point of the commit. And that is true, but we probably want to know some more information, right? For example, we probably want to know what was the time when you added this commit. We probably want to know who added this commit because we want to be able to blame this person later. So Git needs to know some, let's call it meta information about the commit. And this is where the third type of object comes into play. And this is an object that you are all already familiar with because this is the actual commit object. So the commit object contains some metadata about the commit. And very importantly, it has a pointer to the tree object, which is tied to this commit. And it has a checksum header of its own because every object in Git has a checksum header of its own, again, generated in the same way as before. So these are the 4 objects that Git has created to represent those 2 files that we committed. Now let's take a look at what will happen if we add some changes to our files, right? We go to our index.php, we add some code magic to it. Again, we save, we add it to the staging area, we commit it. And now, since we only edited one file, we only changed the content of one of these files, Git will only create one new blob object. And this new blob object will now represent this new content of our index.php. And Git will create this blob object the same way as before. It will take the full content of your index.php and put it in the blob object. Then it will generate the checksum header, which will now be different than before, because if you remember, it is a hashing function. So if the input changes, the output must change as well. And now Git will go to create the tree object. We didn't add or remove any new file. We didn't add new files. We didn't remove files. So the folder structure is still the same. So it's going to be one tree object. It's still going to have the same list of files, index.php, readme.md. But now the pointer for the index PHP is updated. So now it points to this new blob object representing this new version, this new content of index PHP. As for the readme.md, Git will just reuse the same blob object as before. So the pointer still points to the same blob object as before. Tree object, again, has a checksum header. Again, it's different because the content of this object has changed. So the checksum header must be different as well. And then finally, again, there's the tree object, has some metadata about the commit, has a pointer to the tree object. And very importantly, it has a pointer to its parent. Because every commit in Git has a pointer to its parent, except the very first initial commit. So this is Git's data model, right? This is how it works. To recap, blob objects are used by Git to represent content of your files at the point of the commit. So they are like snapshots of your files at the point of the commit. Tree objects are used to represent the folder structure of your project. Here we had a really simple folder structure. In reality, you probably have some folders, some nested folders. Tree objects can also be nested, so they kind of mimic the folder structure of your project. And then the commit objects, they have some metadata about the commit. And very importantly, every commit has a pointer to its parent. And this allows us to traverse the commit history of our project. And with that in mind, we can now talk about branching. What are branches in Git and how does Git implement branching? So here we have a branch with 3 commits. For simplicity, we're going to abstract it a bit. So here we are only displaying the commit objects. Those blob objects, tree objects, they are still there, but we're going to, for the sake of talking about branches, we don't have to think about them all the time. So we can focus only on the commit objects. So there are 3 commits here. Every commit has a pointer to its parent, except the very first initial commit. Now we type git branch, and Git tells us you are on this branch called main. So let's see what does this mean. If we go to the .git/ref/heads directory, we will see that there is a file there called main. And this file is actually just a text file. So we can use the cat command to take a look inside. If we do, we see that there is this 40-character long string inside. And those of you who are paying extra attention are probably noticing that it's the same. This checksum header is the same checksum header as the checksum header of the last commit on this branch. So there you have it. This is what a branch in Git is. It is just a pointer, or in Git, they call it a reference. That's why it's called the refs folder. It is a reference, a pointer to a commit. And the way it is technically implemented, it is just a text file containing a 40-character long string, right? Very simple and very elegant. But now you may be wondering, if a branch in Git is just a pointer to a commit, how come when you use commands like git log, right, you will get that full long list of commits, because a branch contains a long list of commits. And this is how we usually think about branches, right, as this long list of commits. Well, it is useful to think about branches like that, and you can still think about them like that. But when it comes to Git, Git doesn't need to keep this long list of commits that a certain branch contains. Git doesn't need to keep this long list of commits stored somewhere on your hard drive or in memory, wherever. Git only needs to know about the last commit on that branch. And this is what is called the tip of the branch. So the only information that Git needs to store is the information about the tip of the branch. What is the last commit on this branch? And if and when Git needs to show you this full list of commits, Git needs to know this full list of commits that a branch contains, Git will just generate it in runtime. And it will generate it by going to the tip of the branch and traversing the commit graph. And then Git just generates it. And the reason why this can work is because Git's commit graph is something that is called a directed acyclic graph, which basically means that it is directed so you can go in a certain direction. And acyclic means that there are no round trips. So we can be sure that when Git is traversing this graph to generate this list, it will never be stuck in some while or for loop forever. So this is why this can work. And Git, when it comes to branches, Git only needs to keep the information about the tip of the branch. And when it needs to generate the full list, it will do it on the fly. So this is why creating new branches in Git is a very fast and cheap operation, right? When you type git branch feature, only thing that Git needs to do, it needs to create a new text file called feature, and it needs to put this 40-character long string, the checksum header of the tip of the branch inside. So it's you could implement this script to create these branches in 5 minutes now in any language of your choice. But now that we have 2 branches, again, a question pops to mind, right, is how does Git know which branch we are currently on? Because now we have 2 branches. So what if we make some changes? Where do we put this commit, right? Which branch does this commit go to? And this is where that leaky abstraction again comes into play, because there is a special kind of pointer that is called the head pointer. And you probably, even if you didn't know what it is, you probably heard about it because of that leaky abstraction that Git UI gives you, because you had to use it at some point, probably with the reset command or something like that. And this head pointer is actually, again, just a text file, so we can take a look inside. And if we do, we see that it doesn't contain a 40-character long string, so it doesn't contain a checksum header. Instead, it contains basically a reference to a reference, right? So a head pointer is a special kind of pointer that points to a branch, or it's kind of like a pointer to a pointer or a reference to a reference. And you see at this point, the head pointer points to the main branch, and that this means that currently we are on the main branch. If we would check out to the feature branch, and take a look inside of the head pointer, now we would see, now we are on the feature branch. If we would add a commit now, the feature branch pointer will be updated. So now the feature branch has a new tip. So it has a new checksum header in this feature branch text file, while the head pointer still points to the same feature branch, to the same reference. There is a special situation where the head pointer can actually contain that 40-character long string. So the head pointer can sometimes directly point to a commit. And at that point, you get that weird message that says head is a detached state, and it works, you start to panic, but actually it's no biggie. You can just use the checkout command to point the head pointer back to a certain branch, and everything will be fine. Okay, so now that we know what branches are in Git, we can have some fun about by merging our branches, right? Because this is, again, something that we use daily very often. And we're going to talk about a merge that is actually called a 3-way merge in Git. So let's see how this works, right? You have your commits, you are on your main branch. Let's say it has 2 commits. It has, we're just going to display the last 2 commits. Maybe it has a couple of hundreds or millions of commits, who knows? And now you need to develop a new feature, some new cool features. So you create a branch called feature. You check out to that branch. So the head pointer now points to the feature branch. You apply some cool changes, right? Then you add some more cool changes. And now somebody calls you, I don't know, from support or even your boss, and tells you your production is on fire, nothing works. So then you check out to the main branch fast, you deploy a hotfix, then you realize that your hotfix introduced another bug. So you deploy a hotfix for the hotfix, and now everything is back to normal, right? The production is okay, it works. And now you actually want that cool feature to be present on production, right? You want to merge the feature branch into main. You want to integrate those changes you did, those cool changes from the feature branch, into the main branch. But what does this mean when it comes to Git, right? What does it mean to integrate these changes when it comes to Git and the way Git thinks about branches? Well, if we would go to the tip of the main branch, and if we would now traverse the commit graph of the main branch, we would see that those 2 commits where we apply those cool changes, those cool features, they are not accessible from the tip of the main branch. And if these commits are not accessible from the tip of the main branch, this means that those changes, those nice cool changes we did on the feature branch, are also not present on the main branch. And to make them present, we need to make those commits accessible from the tip of the main branch. And this is exactly what we're going to achieve by using the merge operation, or merge strategy, as they like to call it in Git. So let's see how will the merge strategy achieve this. So we type git merge feature, and there's a few steps to this process. So the first step for Git is to locate the tips of both of our branches, the tip of the main branch and the tip of the feature branch. And the second step is to locate what is called the base for merge base. Merge base commit, or the base for our merge. And what Git does here is it goes from the tip of the main branch and the tip of the feature branch. It traverses the graph until it finds the first commit that is accessible from both of these tips. And this is the base merge commit. And you can think of this commit as the commit where these branches actually diverge, right? This is the point where you did the checkout and created the feature branch. So the branches now diverged. So when you go backwards from the tips of these branches, this is the first commit that is accessible from both of these branches, from both of the tips of these branches. And now that Git has this merge base commit, it will go to the next step, which is to create a new commit, which is called the merge commit. And this commit, as you see, is still a work in progress. But once it is done, it will have a nice and interesting property, right? As you see it, it will have this property that it has two parents, the tip of the main branch and the tip of the feature branch, which means that both of these tips will be accessible from this new commit. But let's first see how Git is actually going to create this merge commit. Git needs to decide what changes is it going to put in this commit. And the way Git does this is by looking at your tree objects and by comparing the versions of your files. Now, here again, we are assuming we have a simple project. So we only have 3 files in our project. So our tree objects contain a list of 3 files. And Git is going to now compare for every file the version of these files that it has on the main branch, on the feature branch, and in the merge base commit. And by version, I actually mean a checksum header of the blob object representing the content of this file. So let's see how this works in action. First file in this list is the index.php. So Git takes a look at the merge base and it sees what is the checksum header of the blob object representing the index.php on the merge base commit. And then it takes a look at the tips of the main and the feature branch to compare it with the information it has stored there as a checksum header for the index.php file or the blob object representing the content of index.php file. And what Git sees is that on the main branch, the checksum header for the index.php file, for the blob object representing the index.php file, is different than on the merge base. And what this actually means is that we added some changes to index.php. Because if you remember, how we create those blob objects is that Git takes the full content of your files and puts it in the blob object. And then it generates the checksum header by taking the content and feeding it to the hashing function. So if the content changes, the output of the hashing function will change as well. So if the same file has a different checksum header, that indicates that we have changed the content of this file. So you see, Git uses these checksum headers of blob objects to indicate that there was a version change in the file. So here Git sees that on the main branch, we added some changes to index.php because the checksum header is different, indicating a version change. While on the tip of the feature branch, the checksum header is still the same as in the merge base commit. So what this means is that on the feature branch, we didn't add any changes to the index.php file. So now Git is smart enough to say, well, if you only change this index.php file on the main branch, then I'm going to take that version of the file and put it into the new merge commit. So this is exactly what Git does. And then it goes to the next file, which is readme.md in our case. And here the situation is a bit more simple because here Git sees that these checksum headers, they all match. So we didn't add any changes to the readme.md file on any of these branches. So Git can just take the information it already has in the merge base commit and put it into the new merge commit. So then Git goes to the last file, which is the app.php. And now again, it says that on the main branch, the checksum header for the blob object representing the content of app.php is the same as in the merge base. But on the feature branch, this checksum header is different, indicating that we have changed the content of this file. So there's a different version of this file. And again, Git is smart enough to say, if you only change this file on one branch, then I can take that version and put it into the merge commit. And this is what Git does. And now the only thing that's left to do for Git is to actually generate the commit object itself, right? To connect all those objects, generate the checksum header for the commit object. And now the final step in our merge process is to update the main branch pointer, to move it. And now it points to this new tip of the merge branch, which is the new merge commit. And now, as I promised you, if we take a look at the tip of the main branch, and if we traverse the commit graph history now, we see that those two commits with those cool changes are now also accessible from the tip of the main branch because it has 2 parents. So all the commits that were previously accessible are still accessible, but now additionally, those 2 commits from the feature branch are also accessible from the tip of the main branch. And if the commits are accessible, this means that the changes we did on those commits are also present in our main branch. So we have successfully integrated those cool changes into our main branch. And this is what merging in Git is. It is a strategy of making commits accessible, because if commits are accessible, then the changes from those commits are also present on your branch. And as I said, This type of merge is called a three-way merge because, as you saw, we had those 3 commits to compare. And there is also a special kind of merge that is called a fast-forward merge. And even though it is a special case, it is actually a bit simpler case. So let's take a look at how does this happen. Again, we have our main branch, and again, we want to develop some nice features. So we check out and create a feature branch in one step by using the -b flag. And we develop some nice feature. We had some cool changes. We had some more cool changes. And now we go back to the main branch and we realize, oh, while we were very productive on the main branch, nobody did nothing, right? Because we're the only ones doing any work in this company. So now we want to integrate those changes into our main branch. And of course, Git could do the same process as before, create that new merge commit, do some comparisons and all that stuff that we just showed. But actually, there is another way that Git can deal with this, and that is a bit more simple. So again, from the tip of our main branch, those 2 commits are now not accessible, right? And the purpose of the merge operation is to make them accessible. And to make them accessible, instead of doing that, creating that new merge commit and then connecting everything and doing those comparisons, Git can actually do something more simple. And if you take a look at these 2 branches, it seems almost as if the feature branch is actually ahead of the main branch by 2 steps or 2 commits. And this becomes a bit more clear if I just slightly update these visualization like this, because now you see, it really seems like as if the feature branch was just ahead of the main branch. So to make those 2 commits accessible, the most simple thing that Git can do is to actually just move the main branch forward 2 commits. And this is why this is called a fast forward merge, because all Git did is just updated the main branch pointer by moving it 2 steps, 2 commits forward. And now from this new tip of the main branch, all these commits are accessible, changes are integrated in the main branch, and everything is fine, right? Yes, but there is a small catch to this, right? And the catch, or I think the word is caveat, but I never know how to say that word, so I should just stick with the word catch. And the catch here is that if you now look at the history of your main branch, it would be hard, or actually it is impossible for you to know that at some point there was this feature branch and you integrated it. To you, it would only look like as if you did all these 4 commits on the main branch. And this, if this is fine with you, then it's fine with me as well, right? But the thing is, some people do like to have this notion, or they do want to have it preserved in their history that there was this feature branch and then we integrated it. And if you do this fast forward merge, then you lose this information. But what you can do is you can tell Git, you can configure it that way, or you can explicitly tell it when you are using the merge command to never do a fast forward merge. So even if the situation is like this, where Git can do a fast forward merge, you can tell it to always do a 3-way merge. So that way, when you look at your history, you will always see that there was this divergence where you did, where you checked out a feature branch, you integrated it, and so on. So again, this depends on your workflow. Some people like to have it like this. Some people don't. Yeah. I like to, my philosophy is everybody does what they like. So now that we talked about merge, now that we know what merging is, we're going to talk about something that's, we're going to have, we're going to talk about the rebase, right? The dreaded rebase. Aside from reset, this is the most notorious of Git commands and considered to be dangerous by some, but not that dangerous if you know what you are doing. So let's talk about the rebase. Again, let's say we have our main branch, we have some commits. Let's say we have these 2 commits. And now we want to create a new feature branch because we want to develop a new cool feature. We add some changes, we add some more changes. And now, again, we have this situation where we have a bug on our main line. So we go there, we fix it, we apply a bug fix. And now we go back to our feature branch because it's still not done, right? We still need to develop this branch. There's still stuff to do there. But, now at this point we stop and think, gee, I really wish if I had that bug fix commit present on my feature branch, because it actually affects my feature branch as well, right? And again, from the tip of our feature branch, this commit is not accessible, meaning that those changes are not on our feature branch, so we don't have it. We don't have that bug fix, right? Now, of course, what you could do is you could use the merge command. So you could merge the main branch into the feature branch and you would have it. This is one way of doing it, but for some reason, let's say you don't want to do it because there's a catch there, because One might claim that your history is going to be a bit messy because you're going to have, first you're going to check out the feature branch, then you're going to merge the main branch to it, then you're going to merge the feature branch back, and this can go back and forth. So you can see why some people would say this is messy, some people say it's not messy, but let's just say now, for now, that we are the people who say this is messy and we would like a better solution for this. Now you may be thinking, if only we had a time machine like Doc and Martin Back to the Future had, if only we could go back to the future, back to the past, right? And first do that bug fix commit on the main branch, and then we would check out and do those changes on the feature branch, right? So this is how our history would look like then when we go back to our future. And looking at our history now, it would look like as if we did that bug fix commit, and then we checked out, made our branch, and from the tip of our feature branch, that commit with the bug fix would be accessible. So the changes would be there and everything would be perfect, right? But yeah, we don't have a time machine, but we do have the rebase command. And this is exactly how our commit history is going to look with the rebase command. But there is a catch, like there was a catch when Doc and Marty go back to the past, because what you do in the past influences the future. So let's see how this works and what the catch actually is. So back to our situation. Here we are. Now we're going to use the rebase command. So we are on our feature branch and we say we want to rebase off of main branch. Again, there's a few steps to this process. And the first step is Git is actually going to do something that they call rewinding the head. So we already saw how Git can move the head forward, or the branch pointers forward. And now it is going to move them back. It's going to move the branch backwards. And it's going to move it 2 steps backwards until it reaches the main branch. And as Git is moving your head backwards, it is taking your commits. So first it's taking the second commit we did, and it is putting it in this temporary storage. Let's think of it like that. Then it moves. I'm sorry if you are hearing this. Some people are too punctual and like to come to movie nights early. Anyways, so now Git is moving your head. So now it's on the first commit. Again, it's going to move the head 1 step backwards again and store this commit in the temporary folder. So now Git is on the main branch. Now Git will move your feature branch and the head pointer forward to the tip of the main branch. And now it will, again, kind of, you can think of it like, now it's going to again check out and create this feature branch. And now Git will reapply those 2 commits it has in the temporary folder in reverse order, right? It is first going to reapply the first commit and then the second. And now, again, if you're paying attention, you might see what the catch is. The checksum header for this commit is actually different than it was before. Even though the changes that Git has reapplied are the same, but the checksum header is different. And the reason it is different is not because Git is being mean and it doesn't like you, but the reason is because they have to be different. Because if you remember how those checksum headers are generated, Git takes the full content of your file and of your object, feeds it to a hashing function. And the piece of information here that for sure has changed about this commit, even though the changes that you did are still the same, is the parent of this commit, because now it has a different parent. And this piece of information is in your commit object. So when you feed this information to the hashing function, the output has to be different. So it has to have a different checksum header. This is why the checksum header is different, even though the changes that Git will apply in this commit are still the same. So then Git will do the same with the second commit. Again, the checksum header will be different. And here we are, right? As I promised, from the tip of the feature branch, everything is accessible. That bug fix commit is accessible, but the catch is checksum headers are different. And this is why people say that rebase command changes history, which is true. History now looks different. There is no way for you to now to know that at some point you did the rebase. It just looks like as if you did all those commits on the main branch and then you checked out and did the feature branch. But also people say it's dangerous, which is true to a certain degree, because you have to be careful as a rule of thumb with the rebase command. If you are on if the feature branch is a branch that you are working on, maybe you are pushing to it or pulling, but it's only you, then you can do this, because after you do the rebase, you will have to force push it. But if there are other people pulling and pushing to that branch and you rebase and force push, then when they pull their changes, all hell breaks loose, right? So as a rule of thumb, if it's your branch and it's only you, then you can do, if you know what you are doing, you can do the rebase. But as soon as multiple people are pushing and pulling from the branch, you probably don't want to do a rebase, or you have to be really in sync with all those other people and tell them what you're going to do. And if you are wondering why would you even do the rebase, if you look at this situation now, if you now want to merge the feature branch into the main, now you can do the fast forward merge. And this is, some people prefer to have nice linear history, and then before they merge the branch to the main line, they always do the rebase, so then they can do the fast forward merge. But again, however you want to use it, it's your workflow, and you should use it however you like. And yeah, if you want to expand on this lecture, I recommend the Introduction to Git by Scott. Again, I cannot pronounce his last name. I basically rehash I used mostly his lecture to base my lecture. I think I have nicer visuals, but his lecture is more thorough, and he also has a book on Git, so very knowledgeable person on Git. Advanced Git for Developers is by Lorna J. Mitchell. It's more on the practical side. Now that you know how Git works internally, you can do some cool things with it, and Lorna will show you how. And yeah, if you want to know some history, Linus Torvalds talk about how and why he, and I think it wasn't just him, it was a few more people, how they created Git. And yeah, if you didn't know, Linus is the guy who created Git, so I guess also explains partially why it's so hard to learn. And yeah, if you need some even more help, yeah, ping me on Twitter, and I have this Git expert that's always ready to answer your questions. And yeah, now I have to you gotta give me a minute to open the doors, and I'm back in just a minute.
Does anyone already have some questions? We could collect them in the chat, for example.
Sorry for the interruption. Yeah, I'm back.
Seems like no question are there because I already asked while you were on the door. Thank you so much for a talk. Thank you, David, so much for a talk. Were two amazing talks tonight. I hope everyone enjoyed them. But seems like. And I would just say we can talk a bit more if you all want. I think Zvonimir will go to his movie night. Yeah. And if anyone wants to have more talks about Angular tonight, I know that Dave will stream at 8 o'clock with someone else. If you want to talk about that, you have now some time to explain your evening.
I'm also gonna just share my slides if somebody's interested in the chat window.
Okay. I will already end the YouTube stream. Thank you all so much for our talks. Thank you all so much for being here. And have a great